guys, so we'll have one more definition to look at before we look at some real life examples. And it says two sets are said to be disjoint if A and B is equal to the empty set, cool, or the null set, which is the same thing as the empty set, right? So if we look at this Venn diagram here, we can see that A intersect B is not equal to anything. It's actually an empty set, cool. So clearly A and B are disjoint in this example, okay? Disjoint. Now, if we find A union B, right, which is what is in A and what is in B, we'd end up with 1, 2, 3, 4, right? And we can also find, if we have a 5 and 6 out here, we can find A union B prime as equal to 5 and 6, right? Everything outside of A and B. Right, A union B prime would be 5 and 6 would be everything outside of A and B. But A intersect B is not equal to anything. There's no intersection in this example. And for this case, A and B are called disjoint. Okay, guys? All right, so we're going to look at some real life examples now, and we're going to look at a set of formulas that we use with these real life examples. Okay? All right, guys, so we're going to look at a real life example here, okay, and see how we can apply Venn diagrams to problems to solve the questions, okay? And it says the number of elements in two sets. Venn diagrams can be very useful in finding the number of elements in certain subsets. And it says here, the example here, in a class of 30 students, 20 played tennis and 17 played football, and 7 played both tennis and football. Find the students who played tennis only and football only. All right. Okay, so the first thing we're going to do, guys, is we're going to draw a Venn diagram. Okay, so let's draw a Venn diagram here, which represents a universal set. Then we're going to put two sets here. One represents tennis only, and the other represents football only. Okay. So we should label these here. We should have tennis and football, so T and F, okay? Now it says in a class of 30 students, 20 played tennis and 17 played football, and 7 played both tennis and football, right? So tennis and football is represented by 7, cool? So clearly in this set here, 7 is the amount that play both, okay? So we can put a 7 in between there. Now, if 20 played tennis, right? To find T only, which would be tennis only, right? We would have to find the amount of students who play tennis only. And to find the amount of students that play tennis only, if 20 played tennis, then 20 minus 7 students would play tennis only, because 7 of them play tennis and football, so the rest, whatever is left out of that 20, would be the amount that play tennis only. So that's 13 students. So the answer for this is actually 13 students. And for football, it's the same thing. If 17 students play football and 7 played both tennis and football, then the amount that played football only, right, would be equal to 17 minus 7, cool, which is 10. So there are 10 players who play both football only, okay? Okay, all right, so we pretty much solved this question, guys, from using the common sense. From using the diction of the intersection, we're able to find what's in between both for tennis and football. And because of this, we were able to find tennis only and football only. So you see how Venn diagrams can be really useful in solving questions. It's really a breeze, guys. And we're going to do some more examples to show you exactly how to solve questions using Venn diagrams. Well, let's look at another example now. All right, guys. All right, so it says here, guys, in a class of 30 students, 21 like math, 12 like physics, and 6 like neither math nor physics. Find the following: those who like math and physics, those who like math only, and those who like physics only. All right, so to solve this question, guys, we do the same thing. We're going to draw a Venn diagram, okay, which represents the universal set, okay. Then we're going to put two circles in there, right? One would represent math only, and the other would represent physics only. Okay, so let's just label those there. We should have a M, and the other one would be P for physics, right? Then it says here 6 like neither math or physics. So we know that there's a 6 outside here that doesn't like math or physics at all. And it says 21 like math and 12 like physics. And we need to find those who like math and physics. So since we don't know how many people like math and physics, we're going to put an X out here. Cool? Because we really don't know. So we're going to put X as the unknown for how much like math and physics. And for the ones who like math, it would be the ones who like math only. Okay? Math only. It would be 21, because we know 21 like math, minus X, which would be those who like math and physics. And the ones who like physics only would be the same thing. It would be 12 in this case, because 12 like physics minus X. Cool? All right, guys. So how are we going to solve this question? Well, the first thing we have to do, guys, is we have to find X. Okay? So let me just remove this physics only here. All right, guys. So remember that there are 30 students in the entire class, right? There are 30 students. Therefore, 21 minus X, right, plus X plus 12 minus X plus 6 should be equal to 30. Cool? All these equations here, all the numbers here, when you add them in total, it should be equal to 30. All right? So we're going to end up with 21 minus X plus 12 minus X plus 6 is equal to 30. Cool? So we're actually, this X gonna cancel this X, and we're gonna end up with 12 plus 21, which is actually 33, plus 6 here, right, minus X is equal to 30. All right, then we're gonna end up with 39 minus X is equal to 30. So if we carry the X over to the right side and 30 over to the left side, we're going to end up with X is equal to 39 minus 30, and X is going to be equal to 9. Cool? So we found how many students like math and physics. It's 9. And the number who like math only would be equal to 21 minus X, which is 21 minus 9, which would actually be equal to 12. And those who like physics only would be 12 minus 9, which would be equal to 3. All right, guys. So it's pretty simple, pretty easy to understand. All you have to do is read the question properly and decipher what you don't know and what you do know, and set it in an equation. And once you set it in an equation, guys, you can solve for any part, math only, physics only, or math and physics. All right, so it's really simple, guys, and we're gonna do some more examples to really solidify this problem set here. Okay, and I'll see you in the next lecture, guys. All right, so we'll finish with this section and we're gonna move on. All right, guys, so that's it, and I'll see you in the next lecture, and remember to do your best and God will do the rest.